Okay, here's Chapter 9, Lesson 6, our essential question. How can I use operations to model real-world fractions? And today we're going to start adding mixed numbers. So that's number with a whole number and a fraction together. Mixed numbers are numbers with a whole number and a fraction. You can decompose mixed numbers to add them. Use the associative property to group the whole numbers and like fractions together. And we'll see how they've done that here. Madison made a fruit salad. She used 3 1/4 cups of strawberries and 2 1/4 cups of blueberries. How many cups of berries did Madison use altogether? So we're taking the 3 1/4 and 2 1/4 and finding the sum. Now what they've done here is taken 3 and made it 1 plus 1 plus 1, and the 2 and made it 1 plus 1 over here. Seems a little tedious, but that's how they arranged it, sum of the whole numbers and like fractions. So then they've taken all the whole numbers here and here and grouped them together into this set of parentheses. And then they've taken the fractions and put them on another parentheses over here using the associative property. So now we've got all these ones, which was 3 and 2, and that makes 5. And then we've got 1/4 plus 1/4, which makes 2/4. So then they're asking me to simplify 2/4. Since 2 is half of 4, I know that the simplest form is 1/2. But you don't have to worry about that part. If you just put 5 and 2/4, that's also fine. So that's how that problem is solved. Okay. Now example 2, you can also write each mixed number as an equivalent improper fraction. So this is a little bit more complicated, but it will work every time. So we've got 1 1/3 plus 2 1/3. So we've got 1 1/3, and since this one whole is equal to 3/3, they've written it as 3/3 plus 1/3. 3/3 plus 1/3 is 4/3. We've got 4/3. And now we're going to change 2 into 3/3 and 3/3 because each one here will make 3/3, which will give us 3/3 and 3/3. And then they've written the 1/3 over here. So now I've got 3/3 plus 3/3 plus 1/3, which gives me 3, 6, 7 thirds. So now that I've got here 4/3 plus 7/3, 4/3 plus 7/3, 4 plus 7, 11. And because we're still dealing with the same parts of a whole, our denominator is still 3. Now you have to take that and separate that out into wholes again. So 3/3 here, 3/3 here, 3/3 here, and then we've got 2 left over. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've still got our 11, and we've got them divided into thirds. So how many wholes do you see that are completely shaded? It would be 3 whole, and this last one would be written as a fraction, 2. That's how 11/3 can be written in a mixed number. And this is handy if you end up with a fraction at the end, like 4/3 or something that is improper. It can be handy to solve it this way, but it will be, initially it will be more complicated and take a lot more steps with the problems that we're looking at. So with the guided practice, we've got 2 3/6 plus 2 1/6. Now they're going to have us write out 2 into 1 and 1, and then this 2 into 1 and 1. And I realize now that the reason they wanted us to do that is because we're remembering that 1 could be written as 6, 6, which would be another way to do it. So this is using that other strategy. For example, number 2, 6, 6 plus 6, 6 plus 6, 6. Oh, what's happening to my pen? Plus 6, 6. Which will come in handy when we're looking at different kinds of fractions. But for now, we're just going to see 1, 2, 3, 4 wholes, which shows us the 4 there. And 3, 6 plus 1, 6 gives me 4, 6. And that's fine if that's your answer. But I'm also going to show you how to make it into simplest form. I see 4 and 6 are both even. So I'm going to divide the numerator and the denominator by the same number. In this case, I'm going to divide by 2 because they're both even. So the whole number is going to stay the same. 4 divided by 2 is 2. 6 divided by 2 is 3. And that is an equally acceptable answer because 2/3 and 4/6 are equivalent fractions. That's how those problems are done. So when you get to the independent practice, it says find each sum and write in simplest form. And again, as I've talked about before, simplest form is not a requirement for the fourth grade framework. So you can draw your fraction models to check, but you do not have to write in simplest form. You can challenge yourself to do simplest form. And what I've done with the reason these are circled is because these are the ones that when you find the sum, they will already be in simplest form. So if you choose to do that extension activity and challenge yourself to find the simplest form, you won't have to do that for these 3 because they're already in simplest form. The rest of them can be reduced down to simplest form once you found the sum. Now, down here, they're asking you for something. Here's the sum, and they're asking which of these 3 would not give you this answer. So 2 of them will, and you have to circle the one that would not represent this answer. Okay, so that's what they're asking you to do on 11 through 14. So I looked through the problem solving and see nothing that's super tricky in here. The only one that can be reduced is number 17. What I would like to challenge you to do if you want to extend your learning on this is to circle or highlight or mark in some way which keywords told you the operation. So did it have the word sum? Did it have the word in all? What word told you what kind of operation you're going to do, whether you're going to add, subtract, multiply, or divide in order to solve these. I'd like you to look for those keywords for 15, 16, and 17, please. And that's your extension activity to challenge yourself on those problems. Now for the hot problem, which I know people don't like to do, this says write a real-world problem using mixed numbers whose sum is 1 3/5. And you can go back and refer to 15, 16, and 17 for examples of how to write a real-world problem. If you have one mixed number and one fraction, that's fine, since your sum is only going to be 1. But this should be the answer. This should not be part of the problem. And then you're just going to create your own story and have it use that keyword that tells you that you're going to find the sum, which is adding, and this needs to be the answer for whatever problem you create. And there's many different options for you there. If you're stuck, go back and look at the examples we've got above. Okay? How can a mixed number be written as a sum? This is basically asking you to put in word form what they've given you in the first example and a little bit the second example, but the first one is probably easier for you to refer back to. So writing out in your own words what it said for you to do in example number 1. And you should be able to do all of this page. If this takes you the full 20 minutes of your work time to get these done, then you can stop here. If you still have time in your 20 minutes, I would strongly encourage you to go through and do some of the homework until you reach your time limit for your work. Thanks.